Hello. So let's look into today's Leetcode problem, which is sliding puzzle. So you are given with a 2 cross 3 board, and this board has a total of 5 blocks, and each of these 5 blocks are numbered from 1 to 5. Additionally, you are also left out with a space which doesn't have a block, and your end goal here is to shift the blocks in such a way that it follows an order of 1, 2, 3, 4, 5, and then the empty space. So the operation that they are asking us to do is whenever you find empty space, you can simply shift it to any possible cell basically. So let's take an example here for a better understanding. Okay, so we have a 2 cross 3 matrix, and let's take this example. I'll represent empty space to be dash for now. So what you are asked to do is convert the pattern, which seems to be like this: 1, 2, 3, 4, 5, and dash. So whenever you find an empty space, you are allowed to do shifting with its neighbor. And by neighbors, what I mean is for this dash, for this empty space, 4 could be a potential neighbor and 3 could be a potential neighbor. So I do a swap for 4, and 4 comes here, dash comes here. Now potential neighbor for this dash is 2, 5, and 4. So let's perform a swap again. So 5 will come here and dash will go there. So you will have to perform this operation until you arrive at the solution. But there could also be scenarios where no matter how many times you do the shifting, you might not be able to get the desired answer. So in such scenarios, you will have to return -1. So they have also given us one of the examples where which is not possible, though they didn't walk you through it, and it's kind of obvious because if you look into this array, I mean this 2 cross 3 array or matrix, and do the flips. Here you can see 5 comes before 4, and you can't actually move the blocks here and there. You can try it by yourself, and you can't sort it in ascending order. So that's not possible. But anyways, these kind of questions are kind of interesting for someone like me because it is like a real world problem, and it kind of excites me. So this question definitely is marked as hard, but if you are able to get the intuition right, get the approach right, this question is pretty straightforward. And let's look into how the solution actually goes like. To be honest, I was not able to think about the intuition as well, but when I surfed through the discussion forum, I got into one of the beautiful solutions for this problem, and they have solved it using BFS. So BFS might not be the you know shining bulb part for this problem, but they have handled it in such a way that everyone can even understand it. So here, I've also jotted down an example or all possible scenarios on how you can do the shifting. So what they have done here is they've converted the complete 2 cross 3 matrix into a 1D array. So if we have a matrix like this, then it looks like this: 1, 2, 3, and 0 is represented by empty space, and then 5, 4. And your end goal is to reach 1, 2, 3, 4, 5, and then 0. Yeah. And so if you look into these kind of problems, right? So, you are allowed to do shifting based on the neighbors. Let's say 0 is present over here, then 0 can be shifted. 0 aka empty cell can be shifted with 1 or 3. That's what I have written here. Similarly, if 0 is present over here, it can be shifted with index number 0, index number 2, as well as index number 4. Supposingly, once we convert the matrix into 1D matrix, then indexing will go like this: 0, 1, 2, 3, 4. Similarly, we have jotted down other possible scenarios as well, taking zeros on all possible cells. So this is the matrix on how it will look like. Given the position of 0, you are allowed to move in these indexes. So you are given with a start position, you want to reach an end position, and for every position of 0, you are also given with the option to explore on all of its possible direction. So if these three conditions are met, then BFS is the way. So here there is no nothing like edge weight or the cost of moving a block from one space to another. So BFS will do its job. So here what they have done is initially they have started to get the beginning position of the matrix, which is for this example it will be 1 2 3 0 5 4. And then what they have done is they have created a visited array and inserted begin, and like in traditional BFS, after you mark the position as visited, you push it into the queue and then start exploring. Here what they have done is as we want to find the minimum cost, minimum distance, minimum number of moves in order to make the ideal 2 cross 3 matrix, we are starting with a distance of 0 here. So Q will be accepting the intermediate position, or uh, the position and the distance to reach that position till that point of time. So you do a simple BFS, you do the iteration and go through all possible scenarios, all possible neighbor of that index, and once you arrive into a destination, that is when you will be returning the distance. So let's. I'm not very much sure on how much time it will take to run through, do a dry run on one complete example. But let's do a dry run, not fully, but up to some limit for our better understanding. So, in this scenario, we are given with a matrix like, okay, let's look into an easier example so that we solve it a little earlier as well. So we have a matrix 1, 2, 3, and we have a 4 here, and we have a 0, and we have a 5 here. So the first thing that we want to do is, let me change this one as well. Find the 0, find the location of 0, find the index of 0, and let me copy down the all possible direction array that is being created as well. Okay. So the first thing that's being done is find the index of 0, which in this case is 0, 1, 2, 3, 4. So if the index of 0 is 4, then we look into the all possible directions of that index: 0, 1, 2, 3, 4. So what they are saying is you can shift that empty space, aka 0, to index 1, index 3, and index 5 as well. So if you do that, let's name these indices as well: 0, 1, 2, 3, 4, 5. So right now you are allowed to do shifting on 1, 3, and 5. 0, 1, 2, 3, 4. So 0 can move to this place, In that scenario, we will mark first. Let's do the shifting. So it will look like 1, 0, 3, 4, 2, 5. We will mark this array visited, and the cost to move to this distance is 2. Similarly, we do BFS on remaining two neighbors. I mean, explore the remaining two neighbors. So we have done swap with index number 1. Now we will try do it for index number 3. So in that case, the intermediate matrix will look like 1, 2, 3, 0, 4, 5. And same here also the total cost will be current cost plus 1. And the last option is exploring the last neighbor as well, shifting the empty space to the last location as well. Then it will be 1, 2, 3, 4, and fourth index will be replaced by 5, which will be 5 and 0. So when you find this position, that is when you should be returning the distance, current distance. So whenever you do the exploration, whenever you explore a node to its neighbor, you will increment the distance by 1 and push it in the queue. And in the end, if you find an idle position, you return the distance which was currently popped out from the queue. That's it. And there could be a few scenarios where you visit all possible directions for a given input and still not find it. And in such scenarios, what you do is return -1 simply. So the code is pretty straightforward. You can simply go through the code. Um, so yeah, that's pretty much it. Thanks for watching.